Hi everyone, I'm Chunbiao, come from School of Artificial Intelligence, London University of Information Science and Technology. Today I would like to present our paper, Offset Boosting Regulated About Stability, which includes 6 parts totally, mainly on periodic coexisting attractors from trigonometric function, doubling coexisting attractors from offset boosting, and dynamics editing from offset boosting. What is offset boosting? Offset boosting means eddy shift in the phase space with eddy dimension. Here, like a napper at different positions, or like a person on the left or on the right. Taking an example based on the famous three-dimensional Hahn-Rose system, which means HR model, like here. The waveform of xt and yt, like the green plots, and therefore typical chaotic attractors in different plane is here. This is attractor in the plane of xy plane. So, how to realize offset boosting? Here, just put a constant n in any dimension, like let z to be z at n, then different constants n will take the attractor up or down accordingly, like these attractors in color. Here, different position of the attractor are come from different constants. Similarly, let y to be y at m, then the attractor will shift in the dimension of y. Different m, just put the attractor in different position in the dimension of y. Offset boosting provides a good approach for attractor reproducing, like clone technology. Offset boosting can produce any number of coexisting attractors or double coexisting attractors, like reproduced sheep or geese, double like this. Let's see periodic coexisting attractors from trigonometric function. If we take sine function of 0.1 y instead of y, the original chaotic attractor will be reproduced in the y dimension. Similarly, if we take tangent function of z here, the attractor will get its produced in the z dimension, obeying the period defined by the tangent function. Here, take two functions, sine function and tangent function. Together, the original attractor will get reproduced both in the y dimension and z dimension. Applying other functions such as absolute value function combined with offset boosting here, the original attractor will get doubled. Just look at here. Let y to be absolute y minus 8. Two attractors show up in the dimension of y. Similarly, let z to be absolute z at 2.8. Two attractors stand both sides of z equal 0. Multiple substitutions will bring more attractors, such as let z to be absolute z minus 0.5, and let y to be absolute y minus 8. Therefore, 4 attractors show up. Accordingly, standing in the dimension of y and z. Moreover, in a dynamic system, many different attractors can also be connected into phase space. Like here, different colors of flowers can be put together in a box. In system 2, when the parameter g varies in 0 to 8, different dynamics show up, like chaotic and periodic solutions. All these solutions can be selected into phase space when applying the method proposed in the paper, Dynamic Editing Based on Offset Boosting. Typically, limit cycles and a chaotic solution can be collected into phase space accordingly. If we design a suitable piecewise linear function. Okay, here is a concluding and a discussion. Generally, offset boosting shows its strong power for producing coexisting attractors with the same or different shapes. Various functions can be introduced for embedding offset boosting, and therefore various regions of multistablity can be obtained due to the modulation of nonlinear offset boosting. A general approach can be constructed for managing coexisting trackers and free dynamics editing. Here are the main references for this work. Typically, we can check these papers like dynamics editing, doubling the coexisting attractors, and a low chaotic oscillator with free contour. Yeah, we can check these papers for better understanding. Thanks for listening, and welcome to London University of Information Science and Technology.